I work with the Goodhue County SWCD, so the Soil and Water Conservation District in the town of Goodhue. We are an active member in the Cannon River Watershed Joint Powers Organization. That organization was formed in 2020, and it was really to implement a local water plan or comprehensive watershed management plan. So in the late teens, early 20s, we started managing water not on a county boundary, but more on a watershed boundary. Makes sense, right? Water doesn't stop at the county lines. So we developed a plan with the 6 other counties in the Cannon River watershed on how to best do that, how to best manage our water, how to best improve it, how to best work with landowners within the watershed that have an impact on our water quality. So us, the Goodhue, Dakota, Lesueur County, Waseca County, Steele, and who am I missing? Rice. There's 6 of us working together to help improve the water quality. So typical jobs that we do, we work really with private landowners, mainly agriculture landowners, to improve their issues on their fields that they may have. So we install things like dams or water and sediment control basins to help slow the flow of water. We help them with getting grass waterways so water can flow over the surface without eroding. Things like implementing cover crops, improving soil health. Those are typical examples of what we do day to day. And what the Cannon River Watershed Joint Powers Organization helps with is coordinating some of those watershed-wide efforts. So like outreach events, field days, things like that. We do well sealings as part of some of this work together to help improve our groundwater. Shoreline studies in the lakes part of the region. There's a lot of different things that we all have little specialties on. Oh, perfect. Great job on the link there. If you want to learn more, click on there. But really my role here today is just to emphasize some of the work that we do as a group across the watershed. But the real meat of the webinar here is Brooke. So I think I'll hand it over to Brooke. This weekend I went to, side note, went to Wisconsin Dells, and you could tell that I think Wisconsin uses less salt over there, because when we hit the state line, it was a horrible driving. Maybe they just got more snow over there, but the roads were much worse off than the Minnesota roads. So take it away, Brooke.
All right. Well, thank you for the introduction, and thank you for inviting me to be part of your guys' webinar today. I'm excited to share what I have learned over the years. So I will just go ahead and get my screen shared here and get started on introducing myself. So I have been working on chloride for many years now, about a little over 16, in fact. And I've been at the MPCA, the Minnesota Pollution Control Agency, since 2007. And when I first started my work, it was really in relation to that watershed planning that you were just hearing from Bo about, and working with different watershed organizations to figure out where pollution was coming from and what needed to be done to reduce the pollution making its way into our surface waters. And so that's really where I started. So I was very focused, a lot of projects around chloride and figuring out what those sources were, what we could do about it. And then in 2017, we created a new program at the MPCA, the Chloride Reduction Program. And so I helped to create that and am now managing that statewide program that really provides resources, assistance, tools to a wide range of audiences across the state to help them to identify the sources of chloride, as well as figure out what strategies, what can they do to reduce that chloride at the source to prevent it from making its way into our water bodies. So I've been thinking about and working on chloride for many years now, and I am just happy to be here to share a little bit of what I have learned over the years with all of you. So I first just wanted to start with just a basic understanding of when we say salt, what we're talking about. Sometimes we'll refer to it as chloride. And the reason for that is chloride is the main component of salt that we are most concerned about from a water quality perspective. You'll see there's many different types of salts. There's sodium chloride, magnesium chloride, calcium chloride, and potassium chloride, which are all considered salts. And as you can see there, they all have that same last name, that chloride, and that is the part of salt that we are the most concerned about. Now, one of the reasons that chloride is a top priority pollutant for the MPCA is because chloride is essentially a permanent pollutant. And so once chloride bonds with water, it will not break down naturally or be separated naturally. It will remain a chloride ion with that water molecule and travel with that water wherever the water goes. So if that water hangs out in that lake for maybe 10 years or 5 years, it'll stay there, eventually make its way into the groundwater, and then continue to travel down to our deeper aquifers. So it is a permanent pollutant in that it sticks with the water and travels wherever the water goes. And so that makes it very difficult to deal with after the fact. So once we've introduced chloride into our waters, there really isn't anything we can do to remove it or to make it less toxic to our freshwater communities. The only way really to break that bond is reverse osmosis. And so, of course, reverse osmosis is not something that we could implement on a lake, a stream, or a wetland. It's just not feasible. And even to use reverse osmosis, say at a wastewater treatment plant, that would be very expensive and you would still, and energy intense. So we'd be using a lot of additional resources to make that treatment possible. And if that treatment were done, you would still be left with this very highly concentrated brine solution at the end of that wastewater treatment plant that would still need to be disposed of somewhere in the environment. And so, really, the key message here is that chloride is permanent, and we want to prevent as much of it from getting into our waterways as possible, because treating it or trying to remove it after the fact is really not feasible, and it can be very expensive in cases where maybe there is an option to do that. And so, where is all of the salt coming from? Of course, I'm sure all of you are very familiar with the salt that's coming from de-icing activities in the winter months, where winter is finally here, it has arrived. And so it's very apparent, very noticeable that that is a significant source of chloride or salt contributing to our water quality problems. There are also some other sources of chloride that maybe you are not aware of. One is the salt we use in our water softeners. The majority of us here in Minnesota rely on groundwater as our primary source of drinking water. Now, because we're using groundwater, it's in contact with a lot of minerals and it picks up those minerals as it makes its way through the water treatment process. And those minerals then create what we call hard water. And so, when there is hard water, that can clog up your pipes and your water heaters. And so, what we do to address that is to remove some of those minerals through a process called ion exchange, where we use salt to kind of trade off minerals. And the chloride is kind of a byproduct of that process. And so that is also a significant source of chloride making its way into Minnesota's waters. And another primary source is the chloride that is found in fertilizer. I had mentioned earlier that potassium chloride was a salt. Well, that is a pretty significant source in some areas of our state, where potassium is an essential nutrient for plants and in those soils, but that potassium usually has a chloride tagged on that is really just there to deliver the potassium, not necessarily the chloride. So if you see potash or that K, that last number on your bag of fertilizer, that often is going to have chloride in it. We also see chloride used in dust suppressants as well as manure application of fertilizer on agricultural farms. So here's a breakdown. This was done by the University of Minnesota back in 2019. And this was really the first time that we had this big picture look at what are all of the different sources of chloride and try to figure out what are the biggest ones here in Minnesota. So this is created based on purchasing records, research data, fertilizer application rates. A lot of different information was used to kind of pull this all together to try to come up with an estimate. And as you can see, those are the big three that I had mentioned. The purple there is the chloride from de-icing salt, and that's all de-icing salt. So that's salt that's used on our roads, our city streets, our parking lots, our driveways, our sidewalks. So all of that de-icer that's being applied, not just the salt being used by MnDOT. That's often a misconception that I like to clear up, that it's all of the de-icing salt that everyone's using, all the way from homeowners all the way up to our state DOT. And then that blue, that wastewater, that is going to likely be majority coming from water softening activities. There may also be a few other sources, minor sources in there, but largely most of that's going to be from water softener activities. And then that yellow there, that's that fertilizer, that potash that's being used across our state. And that's not just agricultural fields. You can find that also in the fertilizer that's used for turf. So it's a combination of agriculture as well as just turf management. So kind of all of the different uses of fertilizer. And regardless of what the source is, if it's washing off our sidewalks and parking lots into a storm drain, or if it's flowing through our wastewater treatment plants, eventually all that chloride does make its way into our surface waters or our groundwaters. As like I said earlier, wastewater treatment facilities are not set up to remove chloride. And even those stormwater practices, I'm sure you guys have seen some great rain gardens and infiltration trenches. We've come up with some really great technologies over the last 10 years to improve how we treat stormwater runoff before it makes its way into our waterways. Unfortunately, none of those practices will do anything to remove chloride from the water. And so now we'll just get into here why that is important. Now that we know the sources of chloride, where it's coming from, now we'll talk a little bit about the impact that it's actually having on our freshwater communities. So we here in Minnesota, we have a state standard or criteria for chloride that is designed to protect our freshwater fish and insects. That standard is 230 milligrams per liter. So that we adopted, EPA developed that back in the late 70s, and we adopted that same standard. So we adopted what EPA created based on their studies and their research to try to find what is that threshold, what's that limit before it starts to create problems for our freshwater species. And just for some comparison, actually Canada, Environment Canada has their own criteria, and their criteria is 120 milligrams per liter. So you'll notice theirs is a little bit lower than ours. And so they just have some different data, some different research and information that they use to develop that. But Minnesota being so close to Canada, I'm guessing we're not that different. And I would just use this, I like to use this as an example of that. If we really want to be truly protective of our freshwater species, we really should probably be shooting for 120 milligrams to just try to be protective as possible. I know that in some parts of the state, we're still at those lower concentrations of chloride. And so just as a benchmark, let's try to keep it below 100 milligrams per liter. And that should hopefully provide enough room for the fish and the other aquatic insects living in those systems to kind of handle and manage the chloride that they're having to deal with. Now, the reason that it's a challenge for those freshwater communities is it's actually toxic to them. And so it's toxic in different ways. For the fish, it's most directly toxic to those eggs when they lay their fish eggs. They're very soft, and so they're very susceptible to absorbing that chloride, and just fewer and fewer of those eggs will survive as the chloride concentrations increase. That also changes their ability to grow as fast and big and healthy as they normally would be. There was a study done out of Toledo that looked at fish that were living in different pools of water, and they had different concentrations of chloride. And the fish that were living in those pools of water that had the highest concentrations of chloride were much smaller and not as strong as the fish that were living in the cleaner water that had no chloride in it. It also affects their ability to reproduce, and it also affects their ability to compete for food. So our invasive species, like the carp, for example, they are very tolerant of chloride. So they don't mind. The chloride doesn't affect them in the same way. They're not native freshwater fish from Minnesota, and so they don't mind the chloride. It doesn't really affect them. And so they're able to continue to reproduce effectively and outcompete our native fish for resources and for food. And then for those smaller aquatic insects and organisms living in our lakes and streams, it can just be directly toxic to them where they just won't survive, which that can affect the food chain as well. As I mentioned, it is a permanent pollutant as well. And it also has impacts on our lake's ability to mix properly. I'll have a slide about that coming up here. And also does make its way into our groundwater. You may hear this reference that 1 teaspoon of salt permanently pollutes 5 gallons of water. And so that 1 teaspoon in a 5 gallon bucket of water, that just represents that 230 milligram per liter standard. And so that's our way of simplifying that message so that more people can understand just how little salt it takes before it starts to create problems for our freshwater communities. Here's just a few examples of some of the native Minnesota species that are particularly sensitive to chloride. Those dragonfly larvae, as well as mayflies, are pretty sensitive to chloride in those early stages of life. And then it goes all the way up from fish to our native plants, as well as amphibians. Amphibians are similar to fish in that those eggs are very soft. And so if they're being laid in waters that have higher chloride concentrations, it's likely that fewer of those eggs will actually survive. But salt, higher concentration of chloride water or salty water can actually dry out their skin as well. And so just kind of that direct contact with high concentrations of chloride can kind of be directly toxic to our amphibians as well. So these are just a few of the species I like to point out. I'm not sure if anyone, has one of these favorite that they love to enjoy, or maybe go out and do fishing, or just observe them. That these are some of the species that we really are trying to protect here by reducing the chloride that's making its way into our environment. I also mentioned that chloride actually can affect a lake's ability to mix. Mixing is a very natural process for a lake. It's essential because that bottom water needs to come up to the surface in order to come in contact with the oxygen, as well as get that sunlight moving through it. So that just kind of helps keep things moving and keeps our lakes healthy. And what happens when we get a lot of chloride in our lakes is that salt water is actually heavier than fresh water. And what we're starting to see in some of our lakes that have pretty elevated concentrations of chloride is that mixing can be changed, or in some cases can stop altogether. So this chart here on this slide is from Brownie Lake, which is a lake in Minneapolis. And the blue triangles, that's the concentration of chloride at the very top of that lake. So usually when you go out and you collect a water quality sample, you'll get a sample from the top 2 meters of the lake. Now, with chloride, because it is heavier, it's also very important to collect a water sample from the deepest part of the lake. So you have to get something that, get your line dropped all the way down with that container, and you scoop up the water from the very bottom part of the lake. And you can see here when that was done for Brownie Lake, those red dots, that's the concentration of chloride at that deepest part of the lake. So as you can see, a couple of things that stand out from this graph is one, if you were not collecting water quality samples from the deepest part of the lake, you'd be missing a really big part of the chloride story for this lake. You wouldn't realize that the concentrations of chloride down at the deepest part of the lake is hovering around 800 to 900 milligrams per liter. You can also see from this graph that those two lines are not converging. So that means this lake is no longer mixing. So now that bottom water is actually not getting pulled up to the surface to come in contact with the air and to bring that fresh oxygen into the lake. And so we call that meromictic. I don't know of any other examples in Minnesota that we've seen this. So hopefully we can prevent this trend from happening in any other lakes. This lake is also a very deep lake with a narrow surface area. So that kind of sets it up to struggle a little bit with lake mixing anyway. But we do have some lakes that are now only mixing, say, 2 times a year when they used to mix 3 or 4 times a year. So this is just a really good message to make sure that we're monitoring appropriately for chloride, and that we are paying attention to the overall mixing and the ecosystem of the lake, because that's going to have a lot of other negative impacts of not mixing is going to then change the lake as an ecosystem. We have been looking at chloride for many years now, and as well as many of our local partners who also do their own water quality monitoring, and they share that data with the MPCA, we're able to pull all of that information together. And here is a map just showing all of the lakes, the streams, and wetlands where we have collected samples for chloride. And the ones that are either in red, those are the lakes and streams and wetlands that are already above that 230 milligram per liter standard. And the orange are what we're calling high risk. So they're not impaired, but they are within 10% of the standard. So that's about 207 milligrams per liter. Now, if I could go back like 10 or 15 years ago, I would have set that high risk at 100 milligrams per liter, knowing now some of this newer research, newer information that has come out with Canada's criteria being 120. And actually, the state of Michigan didn't have a chloride standard until recently, and they designed their own. And so they looked at the most current research and information as well as some local data, and they came up with 150 milligrams per liter. So if I wanted to go back and try to like get a better handle on this, I would probably want those orange ones to signify any waters that are, about 100 or 120 milligrams per liter. So as you can see, we have many across the state. We have 54 that are already exceeding that standard, and we have another 13 that are on the draft impaired waters list. The impaired waters list is a list that we put out every 2 years that looks at all pollutants and says, okay, here's where we've monitored. These are the lakes and the streams and the wetlands that we have found have too much of any given pollutant in them. And so every 2 years, we kind of evaluate the available data that we have. So you'll see that there's a big cluster in the 7-county metro area. That is twofold. One is when we evaluated all of the chloride data that we had at the MPCA, about 80% of that data was from the TCMA. So we have a lot of information. We have a lot of local partners, a lot of watershed organizations and joint powers organizations and cities who are doing their own water quality monitoring and sharing that data with us. So we just have a lot of information in the metro area. So we're very well informed on kind of what is the status of chloride in the majority of our surface waters in the metro area. We also have a lot of impervious surfaces, 2/3 of the state living in this area for many years. So there's been a lot of de-icing activities happening over the years in that area. As though we've continued to look at other places outside of metro areas, now that we know water softening and fertilizer can also be significant sources of chloride, we are monitoring at water bodies that are not just in urban areas. It used to be thought that chloride was just an urban or a metropolitan type of a problem, but now we know that it is not. And so we are monitoring more and more water bodies. We still have some work to do, but this gives us a pretty good idea of kind of where we stand as far as how are we doing with chloride. The Metropolitan Council has been collecting chloride data on the large river systems in the metro area for over 30 years now. So that's really valuable to have that very long-term data set to see kind of the trend. Now, the concentrations that we're seeing in these large river systems are relatively low. As the volume of water gets larger, you kind of dilute out those toxicity impacts for chloride. It's probably like one of the only pollutants where dilution actually does work to try to minimize those toxicity impacts. And so we're not quite near the standard quite yet. I know that on the Mississippi River, the concentrations are more like 50 to 60 milligrams per liter. So we're still relatively low. But those red triangles, those indicate an increase over time. And then that line next to it is actually showing how much of an increase over time. So you can see on the St. Croix River there on the far right, that Stillwater monitoring location, they've seen 110% increase in chloride in the last 30 years. And then in Prescott, 143% increase. So we're definitely seeing a pretty significant increasing trend in these large river systems that we really need to slow down and cut back on, because we really do not, of course, want these larger river systems to also have toxic levels of chloride in them. And so hopefully we can start to reverse that, slow that down, and eventually get some of those gray boxes, which just means we're not seeing any significant changes. And then here's a map showing the condition of chloride in our groundwater. Now, these samples are actually pulled from our shallow aquifers and not those deeper aquifers that we typically will get our drinking water from. But of course, the shallow aquifers or these shallow groundwater layers are connected to those deeper aquifers where we do pull our drinking water from. It just takes a little longer for that water to travel down to those deep aquifers. And what we're seeing from this data is that about 2/3 of the wells that have chloride concentrations exceeding the standard were in urban areas. So we're definitely for the chloride that's making its way into groundwater. We're seeing a lot of that coming from de-icing activities, which would make sense that they would kind of run off of the landscape and infiltrate into the soil and then get into those aquifers. And we might start to see some of that in some of our agricultural areas, but with tile and drain systems, that water might flow off of there pretty quickly and not make its way into the shallow aquifers. So we're definitely seeing an increase. About 40% of the wells that were tested are showing an increase. So they may not be at that standard, but they're showing that it's increasing over time. The one thing to consider here with the chloride in our groundwater is that chloride is not toxic to us as humans. There's not even actually a standard for it because it's not considered a health risk for us. And so, what EPA does have is a secondary taste standard. So, this is a standard that's designed to say once the chloride reaches these concentrations, the water will start to taste salty. That is 250 milligrams per liter. So, very close to that same standard that we're applying to our surface waters to protect those freshwater communities. That's when we start to see our drinking water would taste salty. Now, thankfully, we aren't anywhere near that in any of our deep aquifers here in Minnesota. Unfortunately, though, our friends over in Madison, Wisconsin, they are experiencing salty, tasty drinking water. And so they're having to look at what are they going to do about it. Right now, they've been spending a ton of time trying to reduce the amount of chloride making its way into their systems, but also figuring out a long-term plan of drilling a new well for their community, which of course will be very expensive. So definitely a situation we want to avoid. We want to keep that chloride out of our drinking water systems. In addition to it tasting salty, chloride, I'm sure as you all are aware, is very corrosive. You see the damage it does to our roads, to our grass and vegetation, and it's also the same on our drinking water infrastructure. So if you really get elevated concentrations of chloride going through your water distribution system, it can actually cause corrosion and it can actually release certain metals like lead. So there's an interaction that happens between chloride and metals that we're really just starting to understand here. And this is some research that's come out of the USGS, the United States Geological Survey. And they looked at the different impacts that chloride is having on kind of that corrosiveness in drinking water systems. And so definitely in areas where we do have lead drinking water systems, we want to avoid getting any chloride into those systems because we, of course, do not want to cause the release of that into our drinking water systems. So we're doing good, like I said, here in Minnesota. We don't have any chloride concentrations that are even near the level that would cause this to happen, but it's definitely something that we want to stay ahead of and prevent from happening. There's also been some newer research in the last few years trying to better understand how chloride is interacting with other chemicals and materials that are in the environment. Right now, so far, what we've been working off of is we know that it's toxic to our freshwater communities, but it also has these other negative impacts. I already mentioned that it changes kind of that density of the water and can impact lake mixing. Well, there was a study done out of Maryland a few years ago that looked at how it interacts with metals and nutrients and organic matters that are found within different streams and wetland systems. And so what they're calling here is a kind of creating a chemical cocktail. So when you add chloride, it's now interacting with those nutrients and that organic matter and those metals and in ways that we really haven't studied yet and we don't fully understand. And so this research helped us better understand that impact and that it did see that as the salt increases, heavy metal and nutrient contamination increases as well. So it basically causes the release of these materials into the water. We saw some research actually out of the University of Minnesota that looked at stormwater ponds that saw as the chloride concentrations increased, those sediments actually release the nutrients that they were designed to hold and release them back into the water column to then make its way to our local lakes and wetlands and streams. And so it really can have a lot of different, and every lake and stream and wetland has a little different makeup of what nutrients are there, the organic matter content, what metals are found in it. And so it's really hard to pinpoint exactly how chloride might affect any given water body with all of these different variables to be considering. So there is just a lot of unknown impacts of chloride that I think we're just starting to understand, as just more reason of why we need to figure out some better options to keep chloride out of our environment. Of course, you're all familiar with the infrastructure and vegetation damage. We see it every year. You see, of course, at building entrances get hit the hardest, our vegetation and just our pavement surfaces, as well as our trees. So on the bottom here, this is a picture of a tree that's got what's called witch's broom. And so if you see this unusual branching, that's a result of either that direct salt spray coming off of the road or that salt being absorbed up through the roots into the plant. And so it causes this unusual branching on these trees. That's called witch's broom. And so there's a lot of negative impacts actually that chloride has on trees as well, that we're just starting to get more information, more research out there to help folks understand that side of it. And then the cost. So if you think about how much it costs to use salt, as well as the labor and equipment to apply that salt, and you add in all of those repairs that have to be done at the end of each year because of the damage it causes to our infrastructure, we estimate that we're spending about $1,000 to just over $3,000 per ton of salt that's used. So I think that can be really impactful because we often will turn to sodium chloride or salt because it's considered a cheaper option for managing the snow and ice on our roads. But when you look at the true cost of it and then compare it to maybe some other equipment that might be available, some other materials, or some perhaps more labor intensive ways of getting the snow and ice managed, it makes that seem a lot more affordable when you look at kind of the true cost of using salt. So to address all of this, as I mentioned in my introduction, we actually created a program at the MPCA called the Chloride Reduction Program. We are the first state environmental agency to have a program dedicated to chloride. This has been a key pollutant for the MPCA for over 5 years now, when we worked it into our strategic plan as a pollutant that we really wanted to focus some additional attention on so that we could make some faster progress. And one of the ways that we're doing that is to create this program. And I'm just going to walk you through just a little bit of that program, and then, of course, get into some of the details about our smart salting training program. So one of the first things is to collaborate and coordinate with other programs within the MPCA. We are a large organization. We have a lot of different work going on within the agency. And so it's very helpful to have a program and some key staff who are really dedicated to making sure that we are connecting our programs appropriately to make sure we're kind of getting the most impact we can have in the work that we're doing at the MPCA. One way we've done that is we have created a statewide chloride management plan. So this is a plan that applies to the entire state of Minnesota. That kind of just lays the groundwork for why chloride's a problem, what the current conditions are, and then what are some strategies that we can implement based on all of these different sources to help us reduce chloride and protect our water resources. And we really tried to keep it as broad as possible. So we tried to find something for every different organization and even individuals in the state of Minnesota, because we all have a role to play in this, and everybody's expertise and experience is a little bit different, but is very valuable in helping us combat this. We also have integrated chloride into some of our regulatory programs. So now in our wastewater program, that's a program where we have a permit with wastewater facilities. We are evaluating their chloride potential, the reasonable potential they have to have a negative impact downstream. And now we're putting chloride limits into those facilities as we collect that data and we see if there is going to be kind of what we call reasonable potential to cause any downstream water quality impacts. We have about 100 facilities, just under 100 facilities, who are going to be getting chloride limits in their wastewater permits. We also integrated chloride reduction into our stormwater permits. So those, we call that the MS4 permit. That's the Municipal Separate Storm Sewer System is one of those. And that applies to cities, counties, some colleges and campuses who are responsible for managing a storm sewer network. And we put in some very specific requirements to reduce chloride and prevent that chloride from making its way into their storm sewer network. We also have an industrial stormwater program that has some specific requirements around salt storage, use, and management. We have a website that's dedicated just to kind of that side of the agency's work, that more regulatory side, and kind of how we're integrating chloride into that. So you can check that out if you want to learn more. We also, are coordinating with our monitoring programs and many other assistance programs at the agency, but those are just a few examples that I would have time to cover today. Now I want to talk a little bit about our smart salting training program. Hopefully some of you are familiar with that. If you are not, smart salting is really just a suite of strategies or techniques that we're asking folks to implement that doesn't compromise public safety or public needs and is protective of the environment and those economic impacts for the use of chloride. So it's really been highly focused on managing de-icing salt, but we also are branching out into other areas and are working on a new training around water softening. So here are the trainings that we offer. It's grown quite a bit. It started as a pilot training back in 2007, and in 2020, the MPCA took over that training program, and it is now a statewide smart salting training program. We have trainings for the hands-on winter maintenance professionals, as well as we will be developing a new training for hands-on water treatment professionals. So those who either install, maintain, or have any kind of interactions with those water softening system in homes, businesses, and industries. We also have trainings for those who are more at that managing level and not necessarily the applicators themselves. We have a Smart Salty for property management. This is a great training for those who are responsible for managing properties, who or maintaining buildings, who hire winter maintenance professionals, as well as environmental professionals and those responsible for implementing those new permit requirements that I had mentioned a little bit ago. We also have a level 2 certification that's an organizational certification. So now an entire organization can use our smart salting tool and find ways that their organization as a whole can reduce chloride use and become level 2 certified. We also, in the last 2 years, have created refreshers for our audiences. We want to make sure that we're delivering new relevant content to help keep them kind of on the top learning edge of what's possible, what are the best strategies that can be implemented, and to give us a little more time to dig in deeper into some of the topics that we cover at a high level in our overall training, but can't spend too much time in when we're trying to keep it down to a 6-hour training. So right now we've got Smart Salting 101. We have a weather refresher for winter maintenance, a salt and snow storage, and a liquid de-icer refresher. So these are all open to those who have certifications can come and learn a little bit more about these topics. The reason we think training is important is not only does it benefit the environment, that's of course why we're so dedicated and invested in this training program, but it also can just improve operator effectiveness. It can save the organization money. Everyone who has shared their information with us about implementing practices after training has shown that they have actually saved their organization money within the first year, even after purchasing new equipment. It, of course, reduces damages to our infrastructure and to our properties, and it really does a great job of maintaining and can improve safety conditions, because it's one thing to just go out and throw a product down, but it's another thing to know how that product works and how it can be most effective and if it will actually be effective for the conditions that it's being used in. So being educated on the right amount of salt and how much to use is really important. I think that's one of the best strategies that we can implement. That's one of the safest de-icers to use, is a de-icer that's used by a trained professional. I think actually one of our instructors said that this morning, and we had a parking lots and sidewalk online training this morning that I was part of. Had to leave a little early, but that was one of his way of phrasing it, and I really like that because that's really our key message here. And those who've been through our training have had significant reductions in salt use. So this is from the Mayo Clinic in Rochester, and they were able to reduce their salt use by 60%. And of course, they did not compromise public safety. It's just as safe, if not safer, to walk around their grounds and get through their campus as it was before they made these changes. And in addition to reducing their salt use, they saved hundreds of thousands of dollars. They didn't give us the exact amount, but they did save a lot of money by implementing these practices as well. And so for me, that's really important information to have, because sometimes a property owner or manager may not be on board with changing their practices just purely for an environmental perspective. And so finding other incentives, other benefits to implementing these strategies can be really helpful if you're having a tough time convincing someone that this is doable, and that it'll be a benefit to them, not just the environment. We do have a great training promo video where we interviewed some of our past participants, and Mayo Clinic staff is one of them. And so if you want to hear it straight from them, we do have an MPCA YouTube channel, and there is a SALT playlist where we have that interview saved. We also have a brand new workshop that I wanted to make sure you were all aware of, that is for community leaders. And so this is a 2-hour online workshop that is free. And we are encouraging, city council members, any, different members of different sustainability and environmental commissions, board members for watershed districts or associations, administrators of schools and cities, and other interested residents within the community who want to learn more and get more involved. And so that is really focused on higher level policy things that can be implemented. And it's focusing on all the different sources of chloride, not just de-icing salt. So we do have one coming up on February 22nd if you're interested, and I can drop the chat for that registration or drop the link for that in the registration a little bit later. We do have all of our trainings available on the MPCA's website that you can check out and register right online. Some of them are in person, others are online. So when we have a host partner, those are usually the in-person ones. If MPCA is the sole host, meaning we're covering the full cost of those, we're sticking to just online only for those. So we're offering a mix for the different audiences. And so I know that this group is really interested in kind of what you can do. So in addition, maybe you're not responsible for hiring winter maintenance professionals. You still can make sure that the community that you're living in is been through the training program. But here's some like the key basics of what we talk about for that winter maintenance side of things: is physical removal, regular training for staff, being smart about the products we're using, and then of course cleaning up afterwards. So physical removal is going to be the first option that we always want to do first. That's going to be the best option to prevent compaction and make just our lives easier in general. Because once that compaction happens, even using de-icing chemicals doesn't necessarily help to alleviate the problems and the conditions. And so we really want to get out there early and often. And this, of course, is going to save your infrastructure. And this piece of equipment in particular, these rotary brooms, have been extremely valuable for campuses because they can do such a great job of getting straight down to that pavement, where in some cases they can eliminate the need for any chemical or just greatly reduce it. And there are a lot of different tools and options available. Even for homeowners, there's a lot of different ways that you can get active in physical removal with some really good tools. Another key thing that we stress and talk about in our training is pavement temperatures. Not all products are going to work in the same pavement temperatures. And a general rule of thumb is that warmer that the pavement is, the faster the melting will happen. Unfortunately, what we see is a lot of people misunderstand how salt works. They don't understand the science behind it. They don't know that that temperature of the pavement is really going to dictate how fast that product will work, not how much you put down there. You can put down as much as you want. And if you have those super cold pavement temperatures, there will be no melting regardless of how much you put down. Also, you need to know what is in the product that you're using. Typical sodium chloride rock salt, that's only going to be effective at about 15 degrees. So right now, any products that are pretty much just sodium chloride or are primarily sodium chloride are not going to really be effective. So they're not going to help improve the safety, and they're just going to be damaging to the environment. There are some products like magnesium chloride and calcium chloride that do work at those colder temperatures. So we can get down to about 20 degrees, minus 20 degrees for calcium chloride. But you don't need to use nearly as much because you can see there's that little 2 behind the Cl. So it's got kind of double the amount of the chloride. And so those products you don't need to use as much. But even when it gets colder than 20 below, those products, no products are going to work. And that's when you want to just switch to a sand or some other material just for traction. And you have to actually know this is something too that it's not uncommon for even those private contractors who manage snow and ice to not understand that like air temperature and pavement temperature can be very different. So, concrete versus asphalt, if that road or that parking lot is shaded or not, if there's trees around it, bridge decks, of course. So, knowing the actual pavement temperature is really important for the professionals because it can be drastically different depending on those conditions as well as the time of year. Um, for example, MnDOT in some of our cities actually have pavement temperature sensors. And so they have a temperature sensor that's buried right into the pavement, and in some cases below the pavement, so that they know what the subsurface temperature is, as well as the surface and then the air. Those are all really important things to understand and know in order to make sure we're using the right product and the right tool for the job. Another common misconception is that putting more salt down will speed up the process. And really, that's not the case because it's a fixed amount of salt that it will melt a certain amount of ice and snow. So it doesn't really matter if you add more, it doesn't make it work faster. As I just mentioned, it's actually going to be that temperature, which is going to be the biggest factor controlling how fast that product's going to work. So unless you can warm up that surface, there's really not going to be any way to speed up that melting process. And so adding more of the same de-icer is not going to speed up. It's just going to kind of waste that product and cause unnecessary damage to the environment. Now, the use of liquid de-icers. So if you are familiar with brine, that is actually a great way to speed up melting because salt does actually not do anything until it's in contact with water. So just putting down like dry salt on the pavement, it's not going to do anything. It's not going to help manage that snow and ice until it's in contact with water. And so by using liquids, you've essentially activated that salt and it can start doing its job as soon as it hits the pavement. But you do need to have proper training and make sure that you're using the right amount of salt to water ratio so that you don't create icier conditions, which is why we cover that in our training program. One other thing I just wanted to mention here before we move on to some other topics here is that there are no labeling requirements for de-icing salt. And so the package can make any claim that it wants. It can list all of the ingredients or none of the ingredients. It often will not tell you the percentage. And so it may say that it's got magnesium chloride, sodium chloride, and some other products, but you really don't know how much. If it's cheap, generally it's probably going to be mostly sodium chloride. That's just a good general rule of thumb. The cheaper the product is, it's more likely to have just sodium chloride than some of those more expensive chlorides, but that's not always the case. And as you can see here, you can see right on this front package, it says that it contains no salt. Well, the first ingredient on the back is magnesium chloride, and of course, that is a salt. And so I'm not sure what they were getting at when they said contains no salt. And it says it's a natural product. Well, yes, salt is a natural product, but when we're putting it on our roads and parking lots and sidewalks in the amounts we are, it doesn't really matter if it's natural or not. It's still having negative impacts on our environment. So just make sure that you are paying attention to those products and finding out those ingredients. In some cases, you may have to call the manufacturer to find out exactly what ingredients are in the product that you're using. And there is actually no testing standard for making statements about it being pet friendly. So all of these claims that says it's pet friendly, it's not like they did some third-party test to confirm that it's actually safe for pets. As far as I can find, there is no third-party testing to confirm and say, yes, we've tested it. This product is in fact safe for pets. So that's another statement that can often be made on these de-icing salts that may or may not be true. So just like to point that out so that you have all of the information so that you can make the best decision possible. Here's an example of course, too much salt was used. We never really want to see these thick piles of salt clumped up. We want to see it evenly spread. And if you see salt on the surface after you've applied it and the salt or the snow and ice has been melted, that means too much was used and you can just cut back next time. So, we're all just kind of learning and we're all just doing our best. And if you're not quite comfortable cutting back too fast on how much salt you're using, just cut back a little bit each time until you don't see any salt afterwards. And then you'll know that's kind of the right amount of de-icer to use to keep your conditions safe. We do want that spread out, and we recommend to use 4 pounds of salt per 1,000 square feet. 1 pound of salt is about a 12-ounce coffee mug. So if you can think about that, that doesn't really take a lot of salt to create and generate some of that melting. And it should be spread out evenly as well. And only applied to surfaces where it's needed. Maybe you only have a few icy spots, to just sparingly use some de-icer in those icy spots rather than spreading it over the entire driveway or sidewalk. And of course, if you see these lines in the road, that means that someone is progressive, someone's being proactive, and they are out getting ahead of the storm and preventing compaction. They're preventing that bond from happening in the first place, which is going to greatly reduce the amount of chloride making its way into our waters and keep the conditions very safe. There's some training videos available on our website that you can check out if you want to learn more, and encourage you to do that. I do want to get us wrapped up here, so I'm going to go quickly through the water softening. I don't know if this is of interest to this group or not, but I did already mention that we do, about 75% of us do rely on drinking water, and that is typically very hard. All those red dots, that's where we have very hard groundwater in our state. So you can see the majority of our state does have hard to very hard drinking water. And so if you do have a water softener, there are some things you can do. Is first make sure that your community, if you're getting it from your city, check to see if they're actually reducing the hardness at the drinking water treatment plant. Many communities are implementing that, and so you may not need one. Or if you have surface water as your primary source, you probably don't need a water softener. And also to know what type of water softener you have. There's on-demand water softeners that are much more efficient than the old timer-based water softeners. And to check, are you softening all of the water in your home or just the indoor water, and just that hot water? And of course, practicing good water conservation practices will also then reduce your use of salt in that water softener system if you have one of those on-demand systems. There's a lot of different options to consider, and it really depends on what your personal needs are. We have a ton of information on our website with fact sheets from the University of Minnesota that looked into this and developed some really easy to use fact sheets to help consumers decide what is the best water softening system, what's the best way to reduce hardness and have the minimal amount of chloride being used. We also have a lot of different assistance that we offer through our training program. I'm not going to get into too much of that because this is going to be more applicable to cities and counties, and kind of more larger organizations. But we do have a tool that helps you understand where the chloride is coming from and then what you can do about it. And this is just an example of a winter maintenance organization. It's actually Edina Public Schools that use the tool to evaluate all their practices, and it comes up with this nice chart that shows those red practices. Those practices are probably using too much salt, and then those advanced practices, the green ones, are those ones that we want folks to transition to. So as you can see here, this particular organization has made some really great progress over the years and are really using the best practices to manage snow and ice on their campus. We also have a newly created chloride reduction grant program. We've offered 2 rounds of grants. We're going to be having another grant round open in probably the next 6 to 9 months. It's been focused on water softening, but really our primary audience is those wastewater communities who need to reduce chloride making its way into their wastewater treatment facility. So it's not open to individuals. We're really looking at that higher level. We're looking at cities and larger organizations to take these grant funds and make some great impacts on chloride reduction in their communities. We also have a couple of loan programs that we just like folks to know about. Some are for small businesses and others are for government entities. And we have our highly successful Green Corps program that maybe some of you are familiar with, and we've integrated chloride reduction into that. And we've had several Green Corps members over the last 5 years who have been spending some of their time working on chloride. You can see by the map, they've been spread out pretty far across our state and have had a really great impact in their communities that can really be long lasting. And so these Green Corps members are 1-year interns that the MPCA pays, and the host site, provides them the guidance and the direction and the work that they're going to do. And in some cases, it can really have a long lasting impact on their community. Like this is just an example from the city of Minneapolis, who's had a couple of Green Corps members the last few years. We also have some additional resources that we've created just to help organizations look at chloride from different perspectives. So this is a model ordinance that a city or a county could consider implementing. We also have a guidance document for if you want to implement a water softening rebate program, and what are all the different steps in having a successful program. And then, of course, we have just a ton of resources. So there are a lot of educational videos, posters that partners from across the state have created, and they've shared with us and given us permission to share with everybody. So we're trying to kind of be a clearinghouse of all of the latest and greatest on educational resources, research, monitoring guidance, all kinds of things that you can find on the MPCA's website. We've gotten permission from others to share that with you. So I encourage you to check that out. And we do a press release every year that you are all welcome to utilize and put in your local newsletters and get out in your communities. I also want to mention before I close things up here that the Hennepin County Chloride Initiative has created a wonderful program called the Low Salt, No Salt Minnesota program. And this is a toolbox for local governments of local government units, such as cities and joint powers agreements, to utilize to help create some kind of hands-on education within their community. It gives them some opportunities to have some presentations, some handouts, so that they can go have a conversation with a property owner or a business owner, and then hopefully encourage them to participate in training and implement some of those practices. But sometimes that first conversation can be really important for getting that property owner or that group on board, and they have a really great toolbox that I encourage you to check out. We have the link on the MPCA's website, but you can also find it through their website as well. And so I don't want to go through, these are just the last couple of slides here on some other educational resources that we have available if anyone's interested. And we have a newsletter that I highly encourage you to subscribe to, so you can stay up to date on all the latest and greatest going on here at the Smart Salting program. So I do want to end there. I can't see the chat if there's any questions, but now would be a great time if you guys had any questions for me. I'd be happy to answer those.
Yeah, thank you, Brooke. That's a lot of really great information, really interesting, and I've learned a lot. We do have a question in the chat, and then I welcome anyone else to enter their questions as well. But there was a question about chloride use for Minnesota and how Minnesota matches up against other northern states on the amount used on a typical year, so the number of pounds. And what approach does Canada take on road treatments to meet their lower concentration standards?
Yeah, so I think, as far as it's hard because we can compare like DOTs a little bit easier than we can compare counties and cities, because even just within Minnesota, there's a lot of variability from city to city and county to county. I think from a DOT perspective, we're kind of right in there. I think that Minnesota, Wisconsin, and Iowa are all, being pretty proactive with taking steps to reduce their salt use and be as efficient as possible with their salt use and implement other tools. I think that Iowa and Wisconsin might be a little bit ahead of Minnesota, but now we actually, I know that MnDOT has recently embarked on transitioning to a lot more liquids, but that of course is a big investment because you need the proper equipment up front to make that brine, make those liquid treatments, and then to apply it. And so they're really ramping that up across the state. So I think that we'll be getting closer to kind of that use. But once you get away from just our neighbors, the conditions can change pretty drastically. So like, of course, the East Coast, they deal with a lot more freezing rain. and a lot less snow, maybe in general, not in any given year, but on average than what we experience. And so they're going to implement different practices. Now, when you look at the overall use, there's a lot more use on the East Coast. I think they're a little bit behind on kind of us, our kind of core Midwest states, Minnesota, Wisconsin, Iowa, that have been thinking about this maybe a little bit longer. That's been on our radar for a little while longer than it has for some of the East Coast states. But I think that we're doing pretty well. I think that Minnesota and Wisconsin are probably leading as far as our efforts. We definitely, I can say with confidence that Minnesota, we were the first to have a training program. All the other states are kind of borrowing and using our content if they are trying to create their own. And so our winter maintenance professionals have been receiving training for a lot longer than any other state. And I think that that's just only going to be better for our waters. And then for Canada, so, just because they have the standard doesn't necessarily mean they're meeting it. Just like us, right? We have that 230. We're not meeting it in a lot of our lakes and our streams. So I think they're definitely being very active, and they have some great work happening, but they're definitely not they don't have the answers to all of the questions, or they don't have it figured out. And so we're actually learning from each other. So we've learned some things from them, and now they're learning some things from us. And so that's one thing that we're trying to do as a state, is to interact with other state agencies and EPA to kind of all just share information and learn from one each other, so that we're not taking, 6 years before we're like, oh, what are they doing over there in Wisconsin that we're not doing, or vice versa. So we actually have a national chloride collaborative that meets a couple times a year to share information and resources, so that we can all hopefully bring each other along, share information and resources, so that we can get to this endpoint a little bit faster.
All right, thank you. Well, we are over time, so I think if anyone has other questions, please reach out to us directly, myself, Teresa, and we can get the questions to Brooke. And if do you have any parting words, Bo or Brooke, or anything you'd like to say before we get off here?
It's very informative. Thank you, Brooke. Thank you for the time you put into it. Appreciate it.
Yeah, thank you for having me. I appreciate the opportunity. And before we go, I'll drop in the chat when we have that community leaders workshop, if anybody is interested in digging in even deeper than what we were able to today. So thank you for having me. I appreciate it.
Thank you. Yes, thanks again for your time, and we'll wait here for you to drop that in the chat. Okay, and then we'll also share that in our follow-up email to participants. So thanks again.
Great. Thank you, guys. Have a great day.